What if the tools we use to design the future of humanity's journey into space weren't confined to blueprints on a desk or 3D models on a screen? What if, instead, we could step into the cosmos itself, shaping habitats and structures with our own hands, as if the stars were our workshop? This isn't a distant dream. It's the promise of augmented reality, or AR, and it's about to redefine how we think about space architecture. From creating immersive simulations of extraterrestrial environments to enabling astronauts and engineers to collaborate in real time, AR is unlocking possibilities that were once the realm of science fiction. In this video, we'll explore how this groundbreaking technology is transforming the way we design, build, and inhabit the future of space. The cosmos is no longer just a place we look to. It's a canvas we can now step into, and the results will change everything. Space architecture has always been a reflection of the tools and technologies available at the time. Think back to the Apollo era, when engineers relied on hand-drawn blueprints and physical models to design spacecraft. These methods, groundbreaking for their time, were limited by their static nature. Designers had to imagine how a structure would function in space, often running into unexpected challenges only after the hardware was built. Fast forward to today, and we've made incredible strides with digital tools like CAD, computer-aided design, and 3D modeling. These tools have become the backbone of modern design, allowing for more precision and flexibility than ever before. But even with these advancements, there's still a missing piece: the ability to truly immerse ourselves in the designs and interact with them in real time. That's where augmented reality comes in. Imagine stepping into a virtual space habitat, walking through its corridors, and manipulating its components with your own hands, all before a single piece of material is fabricated. AR transforms the design process from a flat, two-dimensional experience into a dynamic, three-dimensional one. It's not just about seeing a design on a screen. It's about feeling like you're inside it, understanding how it will function in the harsh realities of space. This shift is revolutionary, especially when you consider the unique challenges of building in environments like zero gravity or on the surface of Mars. With AR, designers can simulate these conditions, test their ideas, and refine their concepts in ways that were once impossible. But this evolution isn't just about better tools. It's about rethinking how we approach space architecture as a whole. Traditional methods often required compromises, forcing engineers to work within the constraints of their tools rather than the realities of space. Augmented reality flips the script, allowing us to design with the environment in mind from the very beginning. It's a more intuitive, collaborative process that brings together engineers, architects, and even astronauts to create habitats that are not only functional, but also adaptable to the unpredictable challenges of space. As we continue to push the boundaries of what's possible, AR is reshaping the very foundations of how we think about building beyond Earth. And this is just the beginning. Picture this: an astronaut floating aboard the International Space Station, wearing a pair of augmented reality glasses. As they look at a blank wall, a detailed 3D model of a new space module materializes before their eyes, perfectly scaled and aligned with the actual environment. At the same time, thousands of miles below, a team of engineers on Earth is tweaking the design in real time, their changes instantly appearing in the astronaut's field of view. This isn't science fiction. It's the power of augmented reality revolutionizing how we collaborate across the cosmos. The ability to work together in real time, despite being separated by vast distances, is a game changer for space architecture. Traditionally, designing and building structures for space has been a slow, painstaking process. Engineers on Earth would create blueprints, send them up to the ISS or other missions, and wait for feedback. Each exchange could take days or even weeks, but with AR, those delays are eliminated. Teams can now collaborate as if they're in the same room, even if one group is orbiting Earth at over 17,000 miles per hour. What makes this so transformative is the level of precision and efficiency it brings to the table. For instance, an astronaut might notice a potential issue with a module's layout, something that wouldn't be obvious in a 2D drawing. With AR, they can point it out immediately, and the Earth-based team can adjust the design on the spot. This dynamic back and forth not only speeds up the design process, but also ensures that every structure is optimized for the unique challenges of space. Gravity, radiation, and even the psychological impact of living in confined spaces can all be accounted for in real time. But the benefits go beyond just speed. AR fosters a deeper level of understanding and creativity. When architects, engineers, and astronauts can see the same 3D models from their own perspectives, it sparks new ideas and solutions. An engineer on Earth might propose a modification that an astronaut can test virtually, ensuring it works in practice before any physical changes are made. This kind of collaboration isn't just about solving problems. It's about pushing the boundaries of what's possible in space architecture. And it's not just limited to the International Space Station. As we set our sights on Mars and beyond, this technology will become even more critical. Imagine a team of explorers on the Red Planet, tasked with constructing habitats or research facilities. Using AR, they could receive instant guidance from experts back on Earth, ensuring that every structure is built to withstand the harsh Martian environment. The result? A smoother, safer, and more efficient expansion into the cosmos. By bridging the gap between Earth and space, augmented reality is transforming how we approach collaboration in the final frontier. It's not just about building better structures. It's about creating a shared vision for humanity's future among the stars. And with AR, that future is closer than ever. Imagine stepping onto the surface of Mars without ever leaving Earth. The red dust under your boots, the thin atmosphere stretching endlessly before you, and the eerie silence of a planet millions of miles away, all experienced through the power of augmented reality. This is not science fiction. It's the cutting edge of how AR is transforming the way we design for extraterrestrial environments. Space architecture isn't just about building structures. It's about solving problems we've never faced before. How do you create a habitat that can withstand the brutal temperature swings of the moon? Or design a system that keeps astronauts sane during months of isolation on Mars? These are the kinds of challenges AR is helping us tackle. With immersive simulations, architects and engineers can step into virtual recreations of these alien worlds. They can test how materials behave under extreme conditions, like how a lunar habitat might hold up against micrometeoroid impacts, or how a Martian greenhouse could manage the planet's weak sunlight. But it's not just about the physical aspects. AR also lets us explore the human side of space living. How does it feel to spend months in a confined space with limited resources? What psychological strains might emerge, and how can design alleviate them? By experiencing these scenarios firsthand, designers can refine their plans to ensure that future space habitats are not only functional but also livable. Think of it like this: building for space is like preparing for a journey into the unknown. You can't just rely on blueprints and calculations. You need to feel what it's like to be there. AR bridges that gap, offering a level of insight that traditional methods simply can't match. It's like giving architects a pair of virtual boots to walk in the shoes of future astronauts, helping them create spaces that are safe, efficient, and even a little bit like home. And as we push further into the cosmos, this kind of innovation will be the key to unlocking humanity's future among the stars. Picture this: an astronaut floating in a zero-gravity environment, staring at a complex array of wires, panels, and equipment. Now, imagine they're not just staring, they're actively interacting with it, assembling a module or troubleshooting a malfunction, all while wearing an augmented reality headset. This isn't science fiction. It's the future of astronaut training, and it's closer than you might think. Augmented reality isn't just about flashy visuals or gaming. It's a powerful tool for learning, especially in high-stakes environments like space. Traditional training methods, while effective, often rely on static simulations or physical mock-ups. These have their limits. You can't easily replicate the weightlessness of space or the exact conditions of a new habitat on Earth. That's where AR steps in, bridging the gap between theory and reality. With AR headsets, astronauts can immerse themselves in a fully interactive environment that mimics the exact layout and systems of their future space habitat. Imagine practicing the assembly of a life support system or navigating through emergency protocols, all while seeing digital overlays that guide every step. These overlays could highlight critical components, display real-time data, or even simulate malfunctions, allowing astronauts to problem-solve in real time. It's like having a virtual mentor right there with you, guiding you through every challenge. But the benefits go beyond just technical skills. This kind of immersive training builds something equally important: confidence. Space exploration is unpredictable. Systems can fail, environments can shift, and the unexpected is always a possibility. By giving astronauts the chance to practice in a realistic, risk-free setting, AR ensures they're not just prepared, they're confident in their ability to adapt and overcome. Think about it this way: if you were learning to drive, wouldn't you feel more comfortable behind the wheel after practicing in a simulator that feels just like the real thing? The same principle applies here. AR training doesn't just teach astronauts what to do, it helps them internalize their skills, making them second nature. And in the high-pressure world of space exploration, that kind of readiness can make all the difference. This isn't just about making training more efficient, it's about making it more effective. By integrating augmented reality into astronaut preparation, we're not only equipping them with the tools they need to succeed, we're also pushing the boundaries of what's possible in space architecture and exploration. It's a small step for training technology, but a giant leap for the future of space travel. When we think about space architecture, it's easy to focus on the technical challenges: how to build structures that withstand extreme temperatures, radiation, or the vacuum of space. But what often gets overlooked is the human element. After all, these habitats aren't just machines. They're homes for astronauts who need to live, work, and thrive in environments vastly different from Earth. This is where augmented reality steps in, offering a powerful tool to design spaces that prioritize human health, well-being, and productivity. Imagine an architect wearing AR glasses, walking through a virtual model of a space habitat. As they move through the design, real-time data overlays show how astronauts might interact with their surroundings. Are the workspaces ergonomic enough for long hours of research? Is the lighting optimal to prevent eye strain or fatigue? These are the kinds of questions AR can help answer. By visualizing how humans move, rest, and work in microgravity, designers can identify potential pain points before the habitat is even built. Think of it as a way to test drive a space home before it's constructed, ensuring every detail is tailored to the people who will live there. But it doesn't stop at physical comfort. Psychological well-being is just as important in isolated, high-stress environments like space. AR can simulate different lighting schemes, colors, or layouts to see how they affect mood and mental health. For example, maybe a softer, warmer light in communal areas helps reduce feelings of isolation, or a particular arrangement of workspaces fosters better teamwork. These insights allow architects to create environments that aren't just functional, but also nurturing. Spaces that feel less like sterile labs and more like welcoming homes. One of the most exciting possibilities is how AR can address the unique challenges of microgravity. In zero gravity, even simple tasks like opening a cabinet or moving between modules can become hazardous if the design isn't intuitive. AR can highlight areas where astronauts might struggle, suggesting modifications to reduce the risk of injury. Maybe it's adding handrails in specific spots, adjusting the height of surfaces, or redesigning tools to be easier to grip. These small changes, guided by AR, can make a huge difference in safety and efficiency. This human-centered approach is what sets modern space architecture apart. It's not just about building structures that survive in space. It's about creating environments that help people thrive. By integrating augmented reality into the design process, we're not only solving engineering problems, we're crafting spaces that truly meet the needs of their inhabitants. And as we look to the future, this level of thoughtful design will be essential for long-term missions to the Moon, Mars, and beyond. Designing for zero gravity is unlike anything architects have ever faced on Earth. In a weightless environment, the rules of physics we take for granted, like gravity keeping things in place, simply don't apply. Materials behave differently, fluids don't flow as expected, and even the way people move through space changes dramatically. Traditional design tools, which are built for Earth-based conditions, struggle to account for these challenges. That's where augmented reality steps in, offering a groundbreaking way to visualize and address the complexities of microgravity environments. Imagine trying to design a space habitat without knowing how a wall might shift or how water will behave in a weightless setting. Without gravity, liquids can form floating spheres, and materials might expand or contract unpredictably due to temperature changes. These are the kinds of problems AR can help solve. By creating immersive simulations, architects can see how their designs will function in zero gravity long before construction begins. They can test how materials will react, how systems will operate, and even how astronauts will interact with the space. This early insight is invaluable, allowing designers to spot potential flaws and refine their plans before they become costly or dangerous mistakes. Take, for example, the challenge of fluid dynamics in space. On Earth, liquids flow downward, but in microgravity, they move in unpredictable ways. AR can simulate these behaviors, giving architects a clear picture of how water or other fluids will behave in a zero-gravity habitat. This isn't just about convenience, it's about safety. A miscalculation in plumbing or air circulation could have serious consequences for astronauts living in these environments. By using AR to test and tweak designs, we can create habitats that are not only functional but also safe and efficient. As we set our sights on long-term missions to the Moon and Mars, the importance of these tools becomes even clearer. The farther we travel from Earth, the less room there is for error. A habitat on Mars, for instance, must endure extreme temperatures, radiation, and the challenges of microgravity, all while keeping its inhabitants safe and comfortable. AR allows us to anticipate these challenges and design solutions that work seamlessly in these harsh conditions. It's not just about building structures. It's about creating environments where humans can thrive, even in the most unforgiving corners of the cosmos. What's truly exciting is how AR transforms the design process itself. Instead of relying on guesswork or costly physical prototypes, architects can explore and refine their ideas in a virtual space, making adjustments on the fly. This not only saves time and resources, but also pushes the boundaries of what's possible in space architecture. With AR, we're not just solving problems, we're reimagining the future of life beyond Earth. Imagine trying to assemble a piece of furniture with no instructions, just a pile of parts and a vague idea of how they fit together. Now, picture doing that in zero gravity, with limited time and resources, and the stakes being nothing less than your survival. That's the kind of challenge astronauts face when building habitats in space. But here, where augmented reality steps in as a game changer. Modular construction is already revolutionizing space architecture, allowing habitats to be built in sections and assembled in orbit or on other planets. AR takes this process to the next level by providing real-time, hands-free guidance during assembly. Think of AR as a digital assistant that overlays precise, step-by-step instructions directly onto the modules. Astronauts could look through their AR headsets and see holographic markers showing exactly where to place bolts, connect cables, or align panels. This isn't just about convenience, it's about precision. In the unforgiving environment of space, even a small misalignment can have catastrophic consequences. AR ensures that every module is assembled correctly the first time, reducing the risk of errors and saving precious time. But it doesn't stop there. AR can also simulate the entire assembly process before a single tool is used. By creating a digital twin of the habitat, astronauts can practice the build in a virtual environment, identifying potential challenges and refining their techniques. This kind of preparation is invaluable, especially when every second in space counts. And because AR systems can be updated in real time, any changes or adjustments to the design can be instantly communicated to the crew, ensuring they're always working with the latest information. What's truly exciting is how this technology opens the door to building larger and more complex structures in space. With AR guiding the way, modular habitats could evolve from small, basic shelters to sprawling, multifunctional stations capable of supporting long-term missions. Whether it's a lunar base, a Mars colony, or a deep space outpost, AR makes it possible to construct these ambitious projects with unprecedented efficiency and accuracy. The implications go beyond just construction. AR could also play a crucial role in maintaining and repairing these habitats over time. Imagine an astronaut inspecting a module and instantly seeing a holographic overlay highlighting areas that need attention, cracks, wear, or malfunctioning systems. This kind of real-time feedback not only enhances safety, but also extends the habitat, making it more sustainable for future missions. In a way, AR acts as a bridge between human ingenuity and the harsh realities of space. It empowers astronauts to build, maintain, and adapt their environments with confidence, turning what was once a daunting challenge into a manageable and even inspiring process. As we look to the stars, it's clear that augmented reality isn't just a tool for space construction. It's a cornerstone of our future in the cosmos. Now, let's take a closer look at how augmented reality can transform one of the most critical aspects of space exploration, in resource utilization, or ISRU. Imagine landing on Mars with the goal of building a habitat, but instead of bringing all the materials from Earth, you use what's already there. This is the essence of ISRU, harnessing local resources like lunar regolith or Martian ice to create structures, tools, and even fuel. But how do we make this process efficient and reliable? That's where AR steps in. Picture this: an astronaut steps onto the surface of the moon, equipped with an AR-enabled visor. As they survey the landscape, the visor highlights areas rich in usable regolith, overlaying real-time geological data onto their field of view. The AR system doesn't just point out resources, it provides detailed instructions on how to extract and process them. For example, it might guide the astronaut to collect specific types of soil for 3D printing habitats or locate subsurface ice deposits that can be converted into water or oxygen. This level of precision not only saves time, but also minimizes the risk of errors, which is crucial when resources are limited and every decision counts. What makes AR particularly transformative in this context is its ability to simplify complex tasks. Extracting and processing materials in space is no small feat. It requires specialized knowledge and careful coordination. With AR, astronauts can receive step-by-step guidance tailored to their environment, whether they're setting up a mining operation or constructing a 3D printed structure. The technology acts as a real-time mentor, ensuring that even those without extensive geological expertise can contribute effectively. This democratization of skill sets is key to making space missions more scalable and sustainable. Beyond just helping astronauts, AR can also enhance collaboration between teams on Earth and in space. Imagine scientists on Earth analyzing data from a rover and then transmitting that information directly to an astronaut's AR display. The astronaut could see exactly where to drill for ice or which rocks to avoid, all based on insights from experts millions of miles away. This seamless integration of Earth-based expertise and on-the-ground action could revolutionize how we approach resource utilization in space. The implications of this technology are enormous. By reducing the need to transport materials from Earth, AR-enabled ISRU could drastically cut mission costs and make long-term settlements more feasible. It's not just about building a single habitat. It's about creating a self-sustaining infrastructure that supports exploration, research, and even tourism in the future. As we push further into the cosmos, augmented reality could be the tool that ensures we're not just visitors, but permanent residents of the stars. What if we could build entire structures in space with the precision of a surgeon and the creativity of an artist? That's exactly where the combination of augmented reality and three-dimensional printing is taking us. Three-dimensional printing has already transformed space architecture, allowing us to create intricate designs using minimal materials, a critical advantage when every ounce of cargo matters. But when you pair this with augmented reality, the possibilities become even more extraordinary. Augmented reality can act as a real-time guide for three-dimensional printing processes in space. Imagine a holographic blueprint superimposed directly onto the printer, visible through AR glasses or headsets. This setup would allow astronauts to monitor every layer as it's being printed, ensuring accuracy and catching any errors before they become costly mistakes. For example, if a layer isn't aligning perfectly with the design, AR could instantly highlight the issue, enabling quick adjustments. This kind of feedback loop is invaluable in environments where resources are limited and precision is non-negotiable. But it doesn't stop there. Think about the creative freedom this synergy unlocks. Designers on Earth could beam updated blueprints or modifications directly to the AR system in real time, allowing astronauts to adapt structures on the fly. Need to reinforce a section of a habitat? AR could guide the printer to add extra layers exactly where they're needed. Want to tweak the design of a solar panel array? No problem. AR could visualize the changes before the printer even starts. This combination isn't just about efficiency. It's about reimagining how we build in space. By merging the tactile power of three-dimensional printing with the visual precision of augmented reality, we're creating a new frontier in space architecture, one where innovation thrives, mistakes are minimized, and the impossible becomes achievable. And as we continue to push the boundaries of what's possible, this partnership could very well become the backbone of future space colonies, enabling us to construct habitats, tools, and even entire infrastructures with unprecedented speed and accuracy. Imagine floating in the vast emptiness of space, surrounded by the intricate systems that keep a habitat running. Even the smallest malfunction could spell disaster, and astronauts must be prepared to handle repairs with precision and speed. This is where augmented reality steps in as a game changer, transforming the way we approach space habitat maintenance. With AR, astronauts can instantly access a wealth of information right in their field of view. Picture this: an astronaut wearing AR glasses that highlight a malfunctioning oxygen regulator. Instead of flipping through a manual or relying on memory, the system overlays a detailed, step-by-step guide directly onto the component. Each step is visually marked, showing exactly where to place tools, how to remove the faulty part, and even providing warnings if a step is performed incorrectly. It's like having a seasoned engineer guiding you through the process in real time. This technology isn't just about convenience, it's about safety and efficiency. In the unforgiving environment of space, every second counts. AR reduces the likelihood of human error, which is critical when dealing with life support systems or structural integrity. It also cuts down the time needed for repairs, ensuring that habitats stay operational and astronauts can focus on their missions rather than prolonged maintenance tasks. But the benefits go beyond immediate fixes. AR systems can log every repair, creating a digital record that future crews can reference. This means that over time, the system becomes smarter, learning from past repairs to provide even better guidance. It's a self-improving tool that evolves alongside the challenges of space exploration, making it an indispensable asset for long-term missions to the Moon, Mars, and beyond. What's truly remarkable is how AR empowers astronauts to tackle complex tasks with confidence. Whether it's replacing a critical component or inspecting the habitat's exterior for micrometeoroid damage, AR provides a clear, intuitive interface that bridges the gap between technical expertise and practical application. It's not just a tool, it's a partner in exploration, ensuring that the habitats we build in space remain safe, functional, and ready to support humanity's next giant leap. Imagine being thousands of miles away from Earth, surrounded by the vast emptiness of space, with nothing but the hum of machinery and the same metallic walls day after day. For astronauts, this isolation can weigh heavily on the mind, leading to feelings of loneliness, stress, and even depression. But what if there was a way to bring a piece of Earth, or even an entirely new world, into the confines of a space station? This is where augmented reality steps in, not just as a tool for work, but as a lifeline for mental health. One of the most profound psychological challenges in space is the lack of connection to the natural world. Humans are hardwired to thrive in environments filled with color, life, and variety. In the sterile, unchanging surroundings of a spacecraft, the monotony can become overwhelming. Augmented reality offers a solution by creating immersive environments that can transport astronauts to places they miss or have never even seen. Picture this: after a long day of experiments, an astronaut puts on an AR headset and suddenly finds themselves walking through a lush forest, hearing the rustle of leaves and feeling the warmth of sunlight filtering through the trees. Or perhaps they choose to stroll through a bustling city square, surrounded by the sounds of laughter and conversation. These experiences aren't just visual, they're designed to engage multiple senses, creating a powerful illusion of being somewhere else entirely. The benefits of these virtual escapes go beyond mere distraction. Studies have shown that exposure to natural environments, even simulated ones, can significantly reduce stress and improve mood. For astronauts, this could mean the difference between struggling through a mission and thriving in it. By offering moments of relaxation and connection, AR can help combat the psychological toll of isolation, confinement, and the constant pressure of high-stakes missions. It's not just about escaping reality. It's about creating a sense of normalcy and balance in an otherwise alien environment. But AR's potential doesn't stop at relaxation. It can also foster a sense of connection to loved ones back on Earth. Imagine being able to virtually join a family dinner or attend a friend's birthday party, even while orbiting the planet. These moments of social interaction, made possible through AR, can help astronauts feel less isolated and more grounded in their humanity. And when you consider the long-term missions planned for the future, like journeys to Mars, these psychological support systems become not just helpful, they're essential. By integrating augmented reality into space architecture, we're not just building better habitats, we're creating environments that nurture the mind as much as the body. It's a reminder that even in the most extreme conditions, technology can help us stay connected to what makes us human. And as we venture further into the cosmos, these innovations will play a crucial role in ensuring that astronauts can not only survive but truly thrive. Now, let's shift our focus to how augmented reality is breaking down barriers and opening up space architecture to a much wider audience. Historically, designing structures for space has been reserved for a select few: engineers, architects, and scientists with access to highly specialized tools and resources. But AR is changing the game, turning what was once an exclusive field into something far more inclusive. Imagine being able to visualize and manipulate a space habitat design with nothing more than your smartphone or a lightweight AR headset. Suddenly, the tools of the trade are no longer locked behind expensive software or years of technical training. They're right there in your hands, intuitive and ready to use. This shift isn't just about making things easier. It's about empowering a broader range of voices to contribute. Think about it. When design tools become this accessible, people from all walks of life can bring their unique perspectives to the table. A teacher, an artist, or even a student could sketch out a concept for a lunar habitat or a Mars colony, experimenting with layouts, materials, and systems in real time. And while not every idea will be groundbreaking, the sheer diversity of thought could lead to unexpected breakthroughs. It's like tapping into a global brainstorming session where creativity knows no bounds. What's truly exciting is how this democratization could accelerate progress in space exploration. With more minds working on the challenges of space architecture, we're likely to see solutions that are not only innovative, but also more adaptable to the diverse needs of future space travelers. After all, the problems we face in designing for space are as varied as the people who might one day live there. AR gives us the chance to explore a wider range of possibilities, pushing the boundaries of what's possible and bringing us closer to a future where space is truly within reach for everyone. Imagine floating in zero gravity, gazing out a window at the vast expanse of space. Now, picture that same experience enhanced by augmented reality, where every detail is brought to life in ways that make the journey even more extraordinary. As space tourism transitions from a distant dream to a tangible reality, AR is set to revolutionize how we experience the cosmos. It's not just about seeing space, it's about truly living it. One of the most exciting applications of AR in space tourism is its ability to turn every moment into an interactive adventure. Think about stepping into a space habitat, like the International Space Station, and instead of just seeing walls and equipment, your AR glasses overlay rich, contextual information. You could point at a module and instantly learn about its history, purpose, and the groundbreaking science that happens there. It's like having a personal tour guide who knows everything about space, making the experience both educational and deeply immersive. But it doesn't stop there. Imagine looking out at Earth from orbit and seeing AR-enhanced overlays that highlight famous landmarks, weather patterns, or even the impact of climate change. Or picture turning your gaze toward the Moon or Mars, with AR providing real-time facts about their geology, history, and potential for future exploration. These aren't just pretty visuals, they're tools that deepen our connection to the universe, turning passive observation into active discovery. And let's not forget the practical side of AR in space tourism. As passengers adjust to the unique environment of space, AR can offer real-time updates on their journey, things like altitude, speed, or even the science behind the spacecraft's maneuvers. This blend of education and entertainment transforms the trip into more than just a thrill ride. It becomes a learning experience that stays with travelers long after they return to Earth. What makes this so powerful is how AR bridges the gap between awe and understanding. Space is inherently overwhelming, its scale, its beauty, its mysteries. But with AR, we can make it accessible, breaking down complex concepts into bite-sized, engaging insights. It's not just about making space tourism memorable. It's about making it meaningful, ensuring that every passenger leaves with a deeper appreciation for the universe and our place within it. As we look to the future, AR could even evolve to include collaborative experiences. Imagine a group of space tourists using AR to solve a virtual puzzle about the formation of a nebula or working together to simulate a mission to a distant planet. These shared moments of discovery could redefine what it means to explore space, turning it into a collective adventure that bonds people across cultures and backgrounds. In the end, AR isn't just a tool for space tourism. It's a gateway to a richer, more profound connection with the cosmos. And as we take our first steps into this new era of exploration, it's clear that augmented reality will be right there with us, transforming every moment into something unforgettable. As we venture further into the cosmos, the dream of colonizing other planets comes with a profound responsibility, not just to ourselves, but to the environments we encounter. This is where augmented reality steps in, offering a unique lens through which we can explore the ethical dimensions of space architecture. Picture this: before we even break ground on Mars, AR allows us to visualize and analyze the potential consequences of our actions. It's like having a time machine for ethics, showing us the ripple effects of our decisions before they become irreversible. Take mining, for instance. Extracting resources from Mars might seem like a necessary step for building habitats, but what if that process disrupts the planet's fragile equilibrium? With AR, we can simulate the long-term impact of mining operations, projecting how the Martian landscape might change over decades or even centuries. These simulations don't just highlight the risks, they also push us to innovate. Could we design mining techniques that minimize environmental damage? Could we repurpose materials already on the planet to reduce our footprint? AR gives us the tools to ask these questions and explore answers in real time, blending science with conscience. But ethical considerations go beyond just the physical environment. AR can also help us think about how our designs might affect potential extraterrestrial life, even if it's microbial. By modeling how habitats interact with their surroundings, we can ensure that our presence doesn't inadvertently harm any native ecosystems. It's a way of extending the principles of sustainability and respect from Earth to the stars, reminding us that space colonization isn't just about survival, it's about stewardship. What's truly exciting is how AR bridges the gap between ambition and accountability. It transforms abstract ethical dilemmas into tangible visual experiences, making it easier for architects, scientists, and policymakers to make informed decisions. Instead of debating hypotheticals, we can see the potential outcomes of our choices, fostering a culture of responsibility in every stage of space exploration. By integrating ethics into the design process, AR doesn't just help us build better habitats, it helps us build a better future, one where humanity's expansion into the cosmos is guided by respect, foresight, and care. Picture this. You're standing on the surface of Mars, surrounded by a holographic projection of a future habitat. The structure shifts and adapts in real time, adjusting to the harsh environment before your eyes. This isn't just augmented reality at work. It's augmented reality supercharged by artificial intelligence. AI is the invisible force that takes AR from a clever visualization tool to a powerful design and problem-solving engine, especially when it comes to space architecture. But how does this partnership actually work? At its core, AI provides the brainpower to process and analyze the enormous amounts of data required to simulate space environments. Think about it. Designing a habitat for the Moon or Mars isn't just about creating a structure that looks good. It's about predicting how that structure will hold up under extreme temperatures, radiation, and low gravity. AI can crunch these variables in seconds, offering predictions and optimizations that would take humans months, or even years, to figure out. For example, AI can run thousands of simulations to test how a building material reacts to prolonged exposure to cosmic radiation. It can then suggest modifications to the design, ensuring the structure remains both durable and efficient. And it doesn't stop there. AI can also automate repetitive tasks, like generating blueprints or calculating stress points in a design, freeing up architects and engineers to focus on more creative and strategic challenges. The real magic happens when AI and AR work together in real time. Imagine an architect wearing AR glasses, sketching a design in midair. As they draw, AI is already analyzing the sketch, offering suggestions for improvements and flagging potential issues. This seamless interaction between human creativity and machine intelligence is what makes the combination so transformative for space architecture. And let's not forget the bigger picture. Space exploration is all about solving problems we've never faced before. AI's ability to learn and adapt makes it an invaluable partner in this journey. Whether it's optimizing a habitat's energy usage or predicting how a structure will perform during a solar flare, AI ensures that every decision is grounded in data and precision. The synergy between AI and AR isn't just about making designs better. It's about making them faster, safer, and more innovative. Together, these technologies are redefining what's possible, turning the challenges of space architecture into opportunities for groundbreaking advancements. And as we push further into the cosmos, this partnership will only grow stronger, shaping the future of how we live and work among the stars. Imagine trying to have a conversation with someone on Mars, where a single message can take anywhere from 4 to 24 minutes to travel one way. The delay alone makes real-time communication impossible, creating a huge challenge for interplanetary missions. But augmented reality could be the game changer we need to bridge this gap. By integrating AR into communication systems, we can transform how astronauts and mission control interact, even across millions of miles. One of the most exciting possibilities is the use of holographic messaging. Instead of waiting for a text or audio message to travel back and forth, astronauts could use AR to send three-dimensional holograms that convey complex ideas or instructions instantly. Imagine a holographic blueprint of a spacecraft component appearing right in front of an astronaut, complete with annotations and step-by-step guides. This would allow for clearer, more detailed communication, reducing the risk of misunderstandings that could jeopardize a mission. But it doesn't stop there. AR could also enable real-time collaboration, even with the time delay. Picture this: a team of engineers on Earth and a group of astronauts on Mars working together on a shared AR platform. They could manipulate the same 3D model of a habitat or rover, making adjustments and solving problems as if they were in the same room. The time lag would still exist, but AR would make the process far more intuitive and efficient, allowing both teams to stay in sync and make progress without constant back and forth. This kind of technology wouldn't just improve communication, it could fundamentally change how we approach space exploration. By fostering a more connected and collaborative environment, AR could help us share knowledge and expertise across the solar system, accelerating our ability to solve problems and innovate. It's not just about overcoming the challenges of distance. It's about creating a new way of working together, one that's as limitless as the stars themselves. Augmented reality isn't just a tool for astronauts and engineers. It's also a game changer for education and outreach. Imagine stepping into a museum where, instead of static displays, you're handed an AR headset that transports you to the International Space Station. Suddenly, you're floating in zero gravity, watching Earth spin below you, or walking alongside a rover on Mars, feeling the crunch of red dust beneath your virtual boots. This isn't science fiction. It's the future of how we'll learn about space. AR has the unique ability to make the vast, abstract concepts of space exploration tangible. Think about how challenging it can be to explain something like orbital mechanics or the geology of distant planets. With AR, these ideas come to life in ways that textbooks or videos simply can't match. Students could manipulate 3D models of spacecraft to understand how they're designed, or zoom in on a virtual asteroid to study its composition. It's hands-on learning without leaving the classroom, or even the living room. But the impact goes beyond just education. AR can inspire. Picture a child putting on an AR headset and suddenly finding themselves standing on the surface of the moon, planting a flag or collecting rock samples. That kind of immersive experience has the power to spark curiosity and passion in ways that traditional methods might not. It's not just about memorizing facts. It's about creating a connection to the wonders of space, igniting a sense of possibility that could shape a child's future career. And let's not forget the role AR can play in public outreach. Museums, science centers, and even schools can use AR to create interactive exhibits that draw people in. Imagine a traveling AR exhibit that lets visitors explore a virtual space colony, complete with habitats, greenhouses, and labs. Or an app that lets you point your phone at the night sky and see constellations, planets, and even satellites overlaid on the real world. These experiences don't just inform, they captivate, turning passive observers into active participants in the story of space exploration. The beauty of AR in education and outreach lies in its ability to make space feel personal. It's one thing to read about the challenges of living on Mars. It's another to virtually walk through a Martian habitat, seeing how every detail is designed to keep astronauts alive. By making space exploration relatable and engaging, AR has the power to inspire the next generation of scientists, engineers, and dreamers, people who will carry the torch of discovery into the stars. Radiation is one of the most daunting challenges of space exploration, a silent but deadly force that can wreak havoc on both human health and the integrity of equipment. In the vacuum of space, where Earth's protective atmosphere and magnetic field are absent, astronauts and spacecraft are exposed to high-energy cosmic rays and solar radiation. This isn't just a minor inconvenience, it's a critical barrier to long-term missions, especially as we set our sights on destinations like Mars. But here's where augmented reality steps in as a game changer. Imagine being able to see in real time how radiation interacts with different materials and structures. AR can simulate these interactions, projecting a detailed visualization of radiation patterns and shielding effectiveness directly into the design environment. Architects and engineers could use this technology to test various materials, from advanced composites to innovative alloys, and instantly see how well they block or absorb radiation. This isn't just about theory, it's about practical, hands-on optimization. For instance, AR could highlight weak points in a habitat's design, showing where radiation might penetrate and suggesting adjustments to strengthen those areas. This capability becomes even more vital as we plan for missions beyond the Moon. On Mars, for example, astronauts will face prolonged exposure to radiation due to the planet's thin atmosphere and lack of a global magnetic field. AR could help us design habitats that aren't just functional but also safe, ensuring that every layer of shielding is as effective as possible. By integrating AR into the design process, we're not just creating structures, we're building lifelines. But AR's role doesn't stop at design. During missions, astronauts could use AR wearables to monitor radiation levels in real time, receiving alerts and visual overlays that guide them to safer areas within their habitats. This kind of real-time feedback could be the difference between a successful mission and a catastrophic failure. The potential is immense, and as we push further into the cosmos, AR will be an indispensable tool in our quest to conquer the challenges of space radiation. Imagine standing on the surface of Mars, gazing at the remnants of what might have been an ancient settlement. What stories could these ruins tell? What secrets might they hold? As humanity ventures further into space, the field of space archaeology could unlock answers to some of our most profound questions, and augmented reality might just be the key to uncovering them. Augmented reality has the potential to revolutionize how we study and interpret extraterrestrial discoveries. Picture this: a rover sends back images of a mysterious structure on a distant planet. Using AR, scientists could overlay a digital reconstruction of how that structure might have looked in its prime. This isn't just about seeing the past, it's about understanding it. By visualizing the original form and function of these ancient sites, researchers can piece together clues about the civilizations, or even that once existed there. But AR's role in space archaeology doesn't stop at analysis. It could also be a vital tool for preservation. Space missions are often limited in what they can transport, and delicate artifacts might not survive the journey back to Earth. With AR, we could create detailed, three-dimensional scans of these artifacts, preserving them digitally for future study. These scans could then be used to build virtual museums, where anyone on Earth could explore extraterrestrial discoveries in stunning, immersive detail. Imagine walking through a Martian temple or examining an alien artifact up close, all from the comfort of your living room. This technology could bridge the gap between space exploration and public engagement. By making these discoveries accessible through AR, we can inspire a new generation of scientists, historians, and dreamers. It's not just about advancing our knowledge, it's about connecting humanity to the wonders of the cosmos in ways we've never experienced before. And let's not forget the collaborative possibilities. AR could allow researchers from around the world to examine the same artifact simultaneously, sharing insights and theories in real time. This kind of global collaboration could accelerate our understanding of extraterrestrial discoveries, bringing us closer to answering one of humanity's oldest questions. Are we alone in the universe? Imagine trying to grow a salad in zero gravity. Sounds tricky, right? Growing food in space is one of the most critical challenges for long-term missions, and it's not just about keeping astronauts fed. It's about creating a self-sustaining ecosystem far from Earth. In microgravity, plants don't grow the way they do on our planet. Water doesn't flow downward, roots don't anchor themselves, and even something as simple as ensuring the right amount of light becomes a complex puzzle. But here, where augmented reality steps in, offering a solution that could transform space agriculture into something both efficient and sustainable. AR can act as a virtual farming assistant, helping astronauts visualize and manage the delicate balance of conditions needed for plants to thrive. Picture this: an astronaut tending to a hydroponic garden, and through their AR goggles, they see real-time data overlays projected onto the plants. Light intensity, humidity levels, nutrient concentrations, all of it displayed in vivid detail, making it easy to spot what's working and what needs adjustment. Instead of relying on guesswork or waiting for Earth-based scientists to analyze data, astronauts can make immediate, informed decisions to optimize growth. This isn't just about convenience, it's about survival. On long missions to Mars or beyond, every resource is precious. Wasting water or nutrients isn't an option, and AR can help minimize those risks. By simulating different growing conditions, astronauts can test out new approaches virtually before implementing them in real life. For instance, they could experiment with adjusting light wavelengths to see how it affects photosynthesis or tweak nutrient ratios to maximize yield, all without risking a single plant. And let's not forget the psychological benefits. Growing food in space isn't just a logistical challenge, it's a morale booster. Tending to living plants can provide a sense of normalcy and purpose in the isolating environment of space. AR can make this process more intuitive and rewarding, turning space agriculture into a collaborative, creative endeavor rather than just another task. The implications go even further. As AR helps us refine space agriculture, the lessons learned could also benefit farming here on Earth. Imagine applying the same precision and efficiency to urban vertical farms or areas with limited resources. The technology developed for space could help us tackle food scarcity and climate challenges in innovative ways. So, while growing food in space might seem like a niche problem, it's actually a gateway to rethinking how we cultivate life in the most extreme environments. With AR as a guiding tool, we're not just solving the challenges of today, we're planting the seeds for a more sustainable future, both in space and on Earth. Space exploration is a thrilling frontier, but it's also one of the most unpredictable environments humans can venture into. Equipment failures, collisions, or sudden emergencies can happen in an instant, and when you're millions of miles from Earth, every second counts. This is where augmented reality steps in as a game changer for space disaster preparedness. By integrating AR into space habitats and spacecraft, astronauts gain access to real-time, context-aware guidance that could mean the difference between a close call and a catastrophe. Imagine a scenario where a critical system on a space station malfunctions. Without AR, astronauts would need to consult manuals, rely on memory, or communicate with mission control, all of which take precious time. But with AR, vital information is instantly overlaid onto their surroundings. Escape routes could be highlighted on walls, emergency procedures could appear step by step in their field of vision, and even warnings about hazardous areas could be displayed in real time. This immediate access to actionable data transforms how astronauts handle crises, allowing them to respond with precision and confidence. One particularly powerful application of AR in disaster preparedness is its ability to simulate emergency scenarios during training. Astronauts could practice navigating complex emergencies in a virtual environment that mimics the exact layout of their spacecraft or habitat. This kind of immersive training not only builds muscle memory, but also prepares them for the unexpected in a way that traditional methods simply can't match. By the time they're in space, they'll have already experienced these high-stress situations, making them better equipped to handle the real thing. The potential of AR in this context goes beyond individual safety. It could also safeguard entire missions. In the event of a collision or system failure, AR could help teams coordinate their actions more effectively, ensuring that everyone is on the same page and working toward a shared solution. This level of synchronization is critical when resources are limited and the margin for error is razor-thin. Augmented reality doesn't just enhance disaster preparedness. It redefines what's possible in the face of adversity, turning potential disasters into manageable challenges. What's truly remarkable is how AR bridges the gap between human intuition and technological precision. In high-pressure situations, astronauts can rely on AR to provide clear, contextual information without overwhelming them. It's a tool that amplifies their capabilities, allowing them to focus on the task at hand rather than scrambling for answers. By integrating AR into space disaster preparedness, we're not just improving safety, we're empowering humanity to explore further, with greater resilience and confidence than ever before. Augmented reality isn't just a flashy piece of technology. It's a revolutionary force reshaping how we think about space architecture. By blending the digital and physical worlds, AR allows us to visualize and interact with designs in ways that were once the stuff of science fiction. Imagine being able to step inside a virtual model of a lunar habitat, tweaking its layout in real time, or collaborating with a team on Earth while floating in zero gravity. These aren't distant dreams anymore. They're tangible possibilities happening right now. AR is giving us the tools to tackle some of the most daunting challenges of space exploration, from designing structures that can withstand extreme conditions to ensuring the well-being of astronauts living millions of miles from home. What makes AR truly transformative is its ability to make the unimaginable tangible. Think about it. Designing for space isn't like building on Earth. You're dealing with environments where gravity doesn't pull you down, radiation is a constant threat, and every square inch of space matters. AR lets us simulate these conditions, test designs, and refine them before a single piece of material is launched into orbit. It's not just about efficiency. It's about safety, sustainability, and creating spaces where humans can thrive, whether on the Moon, Mars, or beyond. And the potential doesn't stop there. As we push further into the cosmos, AR will become an essential tool for fostering collaboration across vast distances. Astronauts, engineers, and architects will be able to work together in real time, sharing ideas and solving problems as if they were in the same room. This level of connectivity will be crucial for building the kind of settlements that can support long-term human presence in space. Looking ahead, the possibilities are as limitless as the universe itself. Augmented reality is more than just a technological advancement. It's a paradigm shift, opening doors to innovations we can't even fully grasp yet. From enabling sustainable habitats to redefining how we explore and inhabit space, AR is at the heart of this new frontier. Thank you for exploring the future of space architecture with us today. If you found this glimpse into the role of augmented reality as exciting as we do, don't forget to hit that like button, subscribe for more content, and share your thoughts in the comments below. What do you think the next big breakthrough in space architecture will be? Let's keep the conversation going, because the future is being built right now, and it's a future we're all part of.